Okay, good. So today's session is on Istio, so service mesh, which is one of the service meshes that Gidraff is going to talk to us about. So Gidraff is a senior engineer and is going to introduce himself and tell us more about himself after I invite him. But he's an experienced engineer and is going to give us the best that we can get. So we are looking forward to the session. And my name is Kadima. So I'm the moderator for today. So let me take you through. This is the quote of the day: learn as if you will live forever, live like you will die tomorrow. And then, so on the agenda, before the main agenda of the day, here is we are going to have an icebreaker, and then we can share some meeting expectations. Then you'll get to learn about our community. So we start with the icebreaker. So for the icebreaker, and we are going to have 3 questions that you guys are going to respond to. You can respond on the chat, and you can also unmute and speak. So you can just share what is your name, tell us what your name is, and also tell us where you're joining us from, and tell us about how quickly you adjust to trends. So are there any trends that you are adjusting to or resisting? So you can share that as well. So is there anyone who would like to share? So anyone who would like to share? To go first? Any volunteers? You can also type on the chat. Just share your name and also where you're coming from, joining us from, and then you can tell us any trends that you are adjusting to or resisting. Yes. Someone.
I can open the floor. Hi, Samuel. Hi, everyone.
Hello.
So my name is Lona Chepkoech. I'm joining from Kino. And how quickly do I adjust to trends? I think it depends on what is trending. If it's something that I can adjust to, I can adjust. If it's not something that I don't feel like I can adjust to, then I don't. It depends on what is it.
Oh, okay. That is good. Thank you for sharing. Anyone else? So I can see here on the chat, Anisha shared her name, Anisha Daniels, joining from Athi River. So we have Ishasir joining from Mombasa. Are there any trends that you guys are adjusting to or resisting? Or how do you adjust to them? Okay, so I think as we wait for more comments on that, we can proceed, but we'll look at those who will post in the chat. So I can see actually there are more who have posted. Kayo Katis joining from Nairobi, Kenya. We have Karen joining from Thika. She doesn't adapt easily to trends. And then Michael from Transoia. Welcome, Michael. Nisha says, I adjust to those that make sense to me. Okay, that is good. So I also adjust to those that make sense to me. So, but but I'm not a quick adjuster. So I'm cautious when I'm making the adjustments. So can move to the next thing. So some of the meeting expectations that we have for today is that you should be able to mute yourself when you're not speaking. You should raise your hand if you want to speak, and you should use the chat box to write your comments and questions. You should be respectful, and you should also be curious. So about the community, so this event is organized by Nairobi Devops community, and which is a community of DevOps engineers. In our community, we have DevOps enthusiasts, people who are beginning in the DevOps career, and also people who are experienced in the DevOps career as well. So the community provides a platform for those who have the knowledge to share, and for those who want to network and connect and to learn. to get that opportunity to learn from those who are experienced. So our mission is to create a supportive and inclusive community that values diversity and supports learning and growth. Our vision is to be a leading DevOps community in Nairobi and beyond, driving innovation and empowering professionals to excel in their careers. So we have a team, and here are some of our team members. So I am Samuel Kadima, and I'm the founder and also the acting director. So we have Mamun Bwanakombo, who is the assistant director. We have Marceline Mochama, who is the community outreach manager. We have Samson Kalume, who is the programs lead. We have Ian Rotich, who acts as the treasurer and also the assistant community outreach manager. We also have Alvin Dung, who is the project lead, Emma Gachoki. So all these people are in the community channel. So you can, in case you want to reach out to them, you can reach out to them there. So yeah, Emma Gachoki in charge of events and social media, Lawrence Juma, who is the assistant events manager. We have Franklin Odd, who is the administrator, Ivy Chepto, who is a creative manager, Daniel Orega, who is the assistant manager, and Ivan Guyo is the assistant project lead. So these are some of our community members who help organize the events and everything else in the community. So in case you want to join us, you can join us and help in one of the following areas. You can join us and help in running workshops, and then that is becoming a speaker and offering a session, leading a session. You can also connect us with other professionals who are experienced and they could like to, who would be willing to share their knowledge. You could give us feedback on ways you can improve. You can share ideas on how we can make this community better, and also help us by sharing our posts, resharing our posts on other channels, and also sharing your own posts. So if you encounter something that you think can help other people in the community, sharing that in our community, that is in LinkedIn, WhatsApp, Twitter, so on those areas. And then yeah, so if you think you can help us document our activities, let's say you're a photographer or a videographer and you can volunteer to do that, we'll be happy. And then we also need people to join us in also organizing our events. So today we are going to look at service mesh that is going to be presented by Gidraff. And Gidraff, I would like to welcome you at this point. So the floor is yours.
Thank you. Thank you very much, Samuel. I hope I'm clear and everyone can hear me.
Yes, you are.
Okay. Let me just try to adjust my mic. Just give me a second. Mic check. Can you hear me?
Check. Yes, I can.
Awesome. Yeah. So my name is Gidraff Kamande, Karanja, I'm a senior Devops engineer, and in today's session, we're going to be looking at service mesh, and specifically, we're going to also be looking at Istio, which is one of implementation of a service mesh. And to get started, I'm just going to share my slides. Just feel free to post your question or raise a hand if you want to interject, and happily answer your question. So to get started, let me first of all share this. I hope everyone can see this. Mic check. Can you guys see my slide?
Check. Yes, we can hear you. And we can also see the slide.
Awesome. Yeah, so today's introduction is service mesh, introduction to Istio. And to first of all get started, I like to get started by giving out an example or creating a scenario whereby we can learn and try to step back from that and learn different concept of how we can apply service mesh or what service mesh is. And in this case, the first scenario that we're going to look at is a simple application, which is a monolith application, has a monolithic architecture. So this is to say that this application has all the business logic in or running in one single server or in one instance of server, but you can still like replicate this and have like a number of replicas, which you can also like place a load balancer ahead of us to control the load of the traffic coming in into infrastructure. So these are simple like example of application that doesn't require any like complex configuration or doesn't require a lot of things when you're going to production. So first things you need is make sure that your application is resilient by having to what do you call it to make it redundant. That is having too many like server running the same workload. This could be like your API could have like multiple instances of your API running, and then placing a load balancer ahead of it. So that kind of makes the work easy for the servers because the workload will be distributed among all the replicas. But let's say, for instance, maybe you want to decouple this microservice, this monolithic application to have like all these different features standing as their own as individual services, and you might end up having something like this. So we term this as a microservice architecture because we have like different services. We have what we have done here is just we've broken the monolithic application into like small services that perform one and one only like function and does that very well. So in this case, in our case, we have like order service and a catalog service all running, and we also have like a node service, so which is also like which allows to be able to do things such as authorization authentications. So in this case, this might look ideal, but there are some requirements when you're going to production, you have to meet for this to work properly. And also there are things maybe when you, not maybe, sorry, there are those things that you are required to have when you're going to production. So first of all thing is you have to make sure that you have security, and you also have to make sure that these microservices are the communication between these individual microservices is secured, and also you want to be able to have what do you call it? You also want to observe how these different services are operating on your infrastructure. And for these services to communicate, they have to find one another for them to be able to establish that connection so they can exchange data among themselves. So for you to achieve this in a microservice architecture, there are a couple of ways you can go about it. So one of the simplest ways to just have like hard code, like the configuration, so that maybe the out service or the other service knows this out service, and the catalog service knows, okay, I only need to communicate to the other service and maybe the service fee here. But now there arises another problem whereby, let's say for instance, there was some downtime in this catalog service, and what happened when this catalog service goes down is that this other service, because it has some dependency on the catalog service, it's going to crash if it doesn't find it, because it's going to keep on trying to send traffic because all the URL are hard coded for this service, so that becomes a problem. And also for service discovery, it's kind of hard for you to hard code that and also like configure that within your infrastructure for services to be able to like come up without use of like other components or other third-party components that you need to need to be deployed within your infrastructure that will enable you to do things such as to enable things such as service discovery and service registry. So one example is like a zookeeper, but one downside to Keeper is that having experience with Keeper is so complex when setting it up, and also the way it's just like it has like a lot of components that you need to deploy for you to get the service discovery working. The other option, you could have like deploy this on an orchestrator like Kubernetes. So Kubernetes does provide a service discovery mechanism that allows you for this service to be, once you deploy this service, they're able to like communicate with one another without having to hard code the URLs within those services, right? But there are other things such as monitoring, your tools like customized monitoring and observability for your services. But Kubernetes doesn't really provide that, So to address this problem, so we notice that there are a couple of problems that when it comes to microservices, and one of the challenges that we face when dealing with microservices is to making sure that our services are able to discover each other services that they have dependence on. So in our case, we saw that we have like a catalog service and another service which has a dependency upon one another. So for them to be able to like communicate, they have to first of all like find one another and for them to be able to establish that communication. So that's just one of the challenges. Secondly is security. Mainly when dealing with these individual services, they might want to like, if two services are communicating, you might want to encrypt the data that is being transmitted across these two services. And we call that like mutual TLS. So where you want like for these two services, they have to like exchange like what do you call it, these certificate and keys for them to be able to transmit this data securely. So for us to do that, we have to add code. In the case of in the case of what we just saw there, we have to add code most of the stuff for that to happen. So that's another challenge when it comes to when you're dealing with microservices. And we also like so that observability, we might want to have to get insights on how our application is performing when it's deployed on production environment. So these are all the things that you need to consider. Lastly, there is also traffic management. We might want to have control of how what traffic we are allowing to go to a particular service and what traffic we are allowing to go out from a particular service. So to achieve this or to solve this problem, we have to think of an idea of or think of a tool so that can help us to be able to solve this problem at a go. And for us to solve this, we maybe you're asking how can we do this with the help of a tool, right? And that's when that's where service mesh comes in. And you might be asking what service mesh is, and I'm going to explain that in a few. But in simple words, what a service mesh is just a simple infrastructure layer that you can deploy within your infrastructure to allow that these microservices to communicate among one another. And it not only like just provide the networking components that allows you to do for these services to communicate. It also offer you other capabilities that you can also, such as load balancing, such as security, such as also like observability, and some service mesh also like comes with allow for you to also like use add-ons where you can easily integrate with your favorite tools for that you use maybe for monitoring and logging. And from this definition, I just want us to maybe pay attention to these few words here. One of them is network infrastructure, and there's this distributed system to communicate, right? So to further explain this, let's first of all understand what the kind of features that comes that service mesh provide us or offer us, and as we just saw from the challenges that comes with having like a microservice architecture or deploying a microservice architecture in a production environment, a service mesh help us give us some features that allow us to do load balancing, and also we can also allow us to also do like mutual TLS with ease and easily configure that. And also it's provided us with configuration, a way to configure traffic and also apply policies and rules to the traffic that is coming in our infrastructure. And yeah, so it also allows those to integrate with other observability such as Prometheus and Kibana, and we're going to see that shortly. But mainly we're going to be focusing here on one capability, that is load balancing and traffic management. I'm going to reserve the security and the observability part for like another session. Yeah, so moving on. So in regards to tools, we have a couple of tools out there, but most popularly the one that are most popular is Istio. I think it has like most market share in terms of popularity. And it's Istio, it's open source, and there's alternative to Istio, this AWS Mesh, which is a service by AWS that allows you to, that also like offers you the same features like Istio. But the way it's implemented is completely different. The implementation is quite different, but the idea is still the same. Yeah, so let's go deeper. Let's go. I think next we're going to have to deep dive into Istio. And to get started with Istio, we have to first of all define what Istio is. And let's just have like a small definition of what Istio is. This is according to, if you go to their site and Google what Istio is, this is what you come across. But basically, it's an open source service mesh platform that allows you to set up networking infrastructure for your microservices. And yeah, you can use it in like in any cloud platform, be it like AWS, be it GCP or Azure. It works well there. And yeah, it's easy to get started with Istio and get things going. But before we can get to that, we first of all to understand how Istio is underneath. And Istio is mainly comprised of two components. So these are like the major components that Istio is consists of. The first one is the control plane and the data plane. And the data plane is basically a proxy, and a proxy, just to define a proxy, I think a best explanation to a proxy is something that you pass information through to another person. It's just like a middleware that stands between your server and a client. So for instance, you might have a client maybe communicating to a server, but the client might think it's going through directly to the server, but instead it's going through like a proxy. That proxy also like now take the traffic and also like give it to like the upstream server. So that's basically how the proxy works. So there are different various types of proxy, reverse proxy, yeah, and forward proxies as well. So those are just like the proxies. The other component is the control plane, and I think this is one of the, I think the second important like component in Istio, because this is what receive instructions when you give like when you upload your configuration file to Istio. This takes the control plane, basically takes in the Istio to try to translate that rules and apply the rules to your service mesh. So that's the work of the control plane. So also control plane has a number of tools, other components inside it. There's a pilot, there's a gallery. So the gallery here is used to mainly keep the configuration files. There's STD, which is mainly used for, this is it's like an agent that is capable of managing things such as certificates, configurations, things such as certificate agents. Yeah, so that's it from in terms of components that are comprised of Istio. So next on, we're going to understand how Istio works. And first of all, understand that there's something that Istio provides us, which is called like Istio also like it kind of extend Kubernetes in a way. So if you're familiar with Kubernetes, how Kubernetes works, you kind of define your configuration in a manifest file and upload that to a Kubernetes API. through like a kubectl client, and those instructions or those or that step is going to be implemented, and you're going to have like pods deployed or resources deployed within your cluster. So same way, since Istio also like kind of extend Kubernetes in a way, also Istio provide us with some API resources that allow us to define configurations and define configuration for what we, define configurations rules that we want to apply to our service mesh or our network infrastructure layer. And these are the major first to be able to work with Istio, you need to understand how to work with these API resources. And as we're going to say in a few, we're going to see how we can define these resources in YAML files and how we can apply those after we installed Istio in our cluster. I'm going to demo that in a short while. So here, the first API resource that we're going to be looking at is a gateway resource. And basically what a gateway resource is, a gateway resource that is, sorry, not a gateway. A gateway resource, its main work is more of like a load balancer. It's what allows traffic in and out of your mesh. So you kind of have to define this for traffic to come in and get out of your service mesh. So that's just one of the API resource we'll be looking at. The next one we're going to be looking at is a virtual service. And a virtual service basically is a resource that allows us to define rules that we are going to apply to our routing rules that we're going to apply to the traffic coming in. And lastly, we have another service, which is a destination rule. So this basically what does is it basically, since the service rule, they work hand in hand with the virtual service. So the virtual service defines the rules and the destination API defines what is going to happen when the traffic gets to these destinations, right? So that's basically all the three resources that we're going to be needing for this demonstration or for this presentation today. And yeah, I think it would be best time for us to jump into a quick demo and see how we can get to work with those resources that we've seen, or those API resources. But before I can get to jump to a demo, maybe I would like to check things, see whether maybe you guys are still with me. Any questions so far? If you have a question, please do raise your hand.
Any questions, you can also share on the chat. Yes, Tony.
Hello?
Yes.
Can you hear me?
Yes, I can hear you.
Okay. So you've just explained that there's I think three different Istio API resources.
Yeah.
They map one-to-one to like a, because you said there's there are extensions. Istio, you can use Istio as an extension to Kubernetes. So do these resources map one-to-one to like a Kubernetes resource, a custom resource?
Could you come again on that question, kindly?
So you've talked about three different, I think, resources, API resources for Istio.
Yeah.
Yeah. So I just wanted to know if they are like, in their implementation, they are Kubernetes, like they're working hand in hand with Kubernetes.
Yeah. So basically, those resources that I mentioned, that I've just mentioned, that is the gateway. So they're going to be deployed as Kubernetes resources within the cluster. But the way you're going to define them, as we shall see shortly, is they have their own kind of definitions. But it's the way you're defining them is similar to how you define like any Kubernetes deployment or like a pod. Yeah. I don't know whether that makes sense.
Yeah, that does make sense. I think I'll see it more when you do the demo.
Yeah, awesome. You do have any other share, please? Okay.
There are no other questions on the chat.
Okay. All right.
There's one question.
Okay, sure.
So someone is asking, can Istio be classified as a CNI?
I think that's a different topic. Asabi is more of like a service mesh. It's a tool that implements service mesh. CNI, I think, is a different topic. Can you see my screen?
Yes, we can.
Okay. Yes. So first of all, let me find this. Okay. Don't mind that. Sorry. Yeah. So the first thing I'm going to do is first of all I'm going to deploy a mini cube. This will deploy basically a cluster. So I want to switch. Yeah, so I'm going to start my mini cube. Suggestion. Okay, you can just start. Yeah, so yeah. Okay. I know.
What are you sharing on our end? We can just see a gray screen.
Oh, a gray screen. Sorry. I'll try to share again. So I think I'm sharing my terminal. I don't know what you guys are seeing. Someone. Can you see my terminal? Sorry.
No.
Oh, okay. What are you seeing right now?
We're just seeing a gray screen with nothing.
Just okay.
And now we can see Google Meet.
Okay. What about now? Can you see my screen? Can you?
Yeah.
Tell me when you can see my terminal. Okay.
Yeah, we can see your terminal.
Awesome. I just need to confirm whether this one is running. Yeah. So as I was saying, I'm going to deploy a Minikube cluster, and then we're going to get started with deploying Istio. Yeah. So the first thing we're going to need is the first thing we're going to do is we need a Minikube, and we need to deploy Istio, and also need access to like a Docker hub for our images. And yeah, this one is done.
Are you able to zoom a little bit the terminal?
Yeah, sure. Is that better? Can you see that?
Type. It's better, but I think you can zoom in again a little bit. Yeah, I think that will be better.
Okay. Awesome. So now since our Minikube is running, just confirm that. Let's wait for this to load. Yeah. Yeah, so at least we have the company, the cluster running, and you just confirm whether we have any resources running. Yeah, so these are a couple of services running here. I have a couple of pods. So now, so since we've already like done, we already have like a cluster running. The next thing we're going to do is try to. The next thing you're going to do is to try to enable many keep tunneling. So what this will do is it will give us a capabilities of to just give like a load balancer within a local load balancer, which will allow us to be able to reach our services that will be deployed within Kubernetes. Yeah, so what I'm going to do here is I'm just going to run this command. This is going to request for my password so that it can enable this one. So I'm just going to type in password. And yeah, this should start running. Okay, so yes, that's already running something. And since we've already done the first step, we're going to now install Istio into the cluster that we just created. And the way to do that, you can just copy this simple command. But this is assuming that you've already like installed istio.ctl, which is a command line that allows you to easily deploy Istio. But this is not just the only way to do that. So if you go to the Istio documentation, you see that they also have like a Helm chart that you can use to deploy Istio. But this is the this is the way I prefer to do it using a command line tool. So I'm just going to copy this command, and since I've had really done this before, so I'm just going to try and see whether I have Istio running. So what I can do is just going to say Kubernetes, and then just gonna give a namespace. We just want to list the namespace, so it will get NS and see. Yeah, so this is too old, and I'm guessing this is going to like definitely like crash because it's quite old. So what I'm going to do right now, so I'm just going to like try to destroy this and do it from again from scratch. And to do that, we can do simply check whether we have istio.ctl. Yes, so we can easily like remove and install Istio by simply giving this command here, which is istio install. So how are you going to do it? You can do istio install uninstall. Okay. We need to provide this patch for it to like destroy everything. And so yes, we want to remove everything from the cluster. And since this everything is removed, you can just clear this thing up. So let me just remove this. Yeah, so let's just check again whether I have the namespace. So we need to also like remove the namespace here. So have to go. So that has been deleted. The other thing we need to also do is we need to describe this default namespace. Yeah, Yeah, so as we can see here, we have a label here. So this is part of the configuration that we need to do. And since we've already removed Istio, we need to remove this label as well. So we can do this simply by saying kubectl. Just remove the label. Just going to say Istio. Injection. I'm going to give that to now. Okay. So, okay. Just a minute. All right. Okay. So the going to like a new namespace. Page. Yeah. So we create a new namespace called demo, and now we can get started with installing Istio and deploying some workload on this server. And just going to default it. So let me just yeah, so that is done. Then let's try to install. Hey,
I think terminal was lagging behind. Maybe you can stop sharing the video.
Oh, okay, just a minute. Is that better?
I think it will be better.
Okay. Awesome. Yeah. Since we have we need to install Istio, and I'm just going to name to label this. We're going to there's another concept called profiles, but which I'm not going to dive deep. So just in case you're wondering why we have this flag here, yeah. So Istio provides you with a capability to where you can have different profiles you can use according to how advanced or how simple you want your settings or configuration to be, initial configurations to be. So you can just play around with the profile that exists. So it's just like a default profile that you can use. So this has most features that we need to be exploring this presentation. So let's just execute this. Yeah, so this is going to install a bunch of, well, first of all, it's going to create a namespace and deploy some ingress resources, some ingress gateways as well. And once it has finished installing, we can easily validate that this worked. So what we're going to do is we could just there's a nice istio command verify. Let's verify install. So if everything worked, once you run that command, this istio verify install, this will give you a green light and say that everything worked correctly. And yeah, so this seems to have worked correctly. So you're going to clear that up. The next thing you're going to be doing is we need to inject we need to label or annotate the namespace we created, which is this demo. We need to check whether we need to annotate this and give it a label, so that the purpose of that label will be to tell Istio which has been deployed. If you can check here in kubectl, get all in this Istio system namespace. So we can see there's a bunch of things that have been deployed. So we have replicas of egress running, Istio, egress and ingress. So for in and outside traffic coming in and leaving our mesh. And we also have Istio service deployed already. We also have like a bunch of services. Yeah, so this seems to have worked, and all these resources are running correctly. I don't see like any restarts. This seems to be working and ready to receive traffic. And if you notice something here, we have like this ingress, which is pointing to a load balancer. And for the external IP, so if you notice here, we have an external IP. This is pointing out to our Istio, our local, the load balancer that we created. If you remember, we started this command, which kind of create like a load balancer, and this kind of this will connect to the Istio ingress gateway resources that has been deployed. So this will allow traffic to come in to our cluster. So with that out of the way, I think one thing we need to do is now let's go to, let's just try to get NS and the site demo. I want to view it in YAML. So, and as you can see, this is our namespace that we created, and it doesn't have many labels. It only have like one label, which is the name, which is demo. So what we need to do for this to allow Istio to inject sidecar or sidecar proxies into our service pods is we're going to give this a label. Right. So just gonna paste this command here, and what this does is just going to change this to demo because that's what we're interested in. This is going to annotate that particular namespace with this label, which is enable injection in Istio injection. And from here, we try to check it again. We see now this has Istio enabled. And if we deploy like any resource within this, it's going to basically inject some sidecar or deploy some sidecar running alongside your microservices or particular services. So that's just that is done. I think the next thing is we're going to now look at how those configuration, we can set those configuration up. And I'm going to switch up here to terminal, my editor. I'm using a VS Code here, and I have a couple of files that I want to show you guys. And you can easily find these examples on the Istio like documentations. So here, what is going on? We have a couple of resources defined, and we also have another resource defined here. So first of all, let's go through this book info YAML.yaml file, and what we have here is like a usual Kubernetes file, manifestation file. So here we have like the type of service we defining a service and also exposing it to this port, and that's also is on HTTP. We have like a service account and our other services as well here. So let's scroll down. So we have a couple of deployments. These are, if maybe you want to go deep into this, maybe you can look into Kubernetes. We're having like in future we're going to have like a discussion on Kubernetes, and we'll be going deeply into this concept, such as deployment services and other types of resources that you can deploy using Kubernetes. But for example, today we are not going to focus mostly on this Kubernetes manifest file, but mainly what we're interested in is these services here. First of all, we have the gateway service, as you've seen. So this will deploy like the load balancer that we talked about, and we have the virtual service here. So the virtual service, the work of the virtual service is to define rules that will be applied to this host, to all hosts. So in our case, you can see here we have defined the gateway service. You have to connect the two. So there's a gateway service, the booking for gateway, and we also have we are referencing that here on the virtual service. So since so in our case, what will happen is since once we have deployed the service, this is going to be applied, and then when the traffic comes in, it's going to go through the gateway, and once it has gone through the gateway, all the rules that are defined within this virtual service are going to be applied to those services that we are referencing here. This product, this host here. So this is one of the most important configuration, the destination. So because this is going to, this we are referencing to the actual microservice, which is the product page here. So we want this to be applied, and these are applied according in this order. So this one will be executed first. This will follow. And if you had other rules, this is just basic rules. But you can also like explore the options. For instance, if you were to go to the IC documentation, submit. If you go to IC and especially on this traffic management, and let's say this is shooting, it's a request routing. Is that? So if you go to this, you might find there are different types of rules, and you can add to your virtual service. And as you can see here, there are various rules and different fields you can apply to your traffic based on your needs. And as you can see, there's also like take precedence, the routing will take precedence. So what comes first will be applied at first, and then the other one will also be applied later on. Yeah, so that's basically the work of the virtual service. There are type of service that we're going to be looking at. We have a destination rule. This is this basically defines what is going to happen when the traffic gets to that particular destination. For instance, what you can do with a destination rule, you can apply like different traffic policy. So for example, here in this like configuration, we are saying that we want to apply this type of load balancing. Yeah, so the list request, this is just like a simple load balancing. We can do the other ways you can do this. We could change this to like round robin, and there are many other options you could also like apply to like when a traffic reaches a particular destination. So yeah, so something else you can see from this definition is we have like a subset defining here. So you can see we have like version 1 and version 2, but this is of the same host because we have like this. We have two versions of this HTTP package service, as we shall see once we have deployed this. Yeah, so we've seen those three components that we talked about earlier on. So those three resources, this is the destination rule, the gateway service, and also the virtual service. So let's see how we can easily deploy this. You can see them in action. Okay. Yeah, so first of all, just need to make sure that we have all the configuration right. And first of all, let's pick this booking profile, and we're going just going to apply this on what to specify the namespace in the demo. Yes, so this is going to deploy a couple of services, the review service, the review version 1, version 2, the details, and the book info product page. So you can just confirm, can easily confirm that here. So you can change the namespace to demo, and these one are still in progress. They're still like pending. So you can give them a second for them to get into a ready status. And once this has we've done with this one, we're going to now deploy the other resources. But if we can have a deeper look at this, we can notice that from, for instance, let's say this instance, this detail service here. So we can notice that we have like a number of containers. For instance, okay, so about that. Let's look at this. So we can see we have like a number of containers that are running. So we have like the details, and also we have like another init Istio proxy. So this is what has been injected to your pod now. You see. So each and every like service that you're going to deploy, or any Kubernetes resource you're going to add with this, Istio is going to inject a sidecar container that will run alongside your services, and this is what is going to intercept the traffic that comes into your cluster and that leaves your traffic, and that also like read your meshes. So we can safely say that now we have like the mesh configured, and as you can see, we have already like enabled Istio to inject traffic into our cluster. So with that out of the way, let's see whether this one is getting ready. And these are going to take some bit of a time. Let's see. But I think let's try to speed them up by let's try to. This is the reason why these things are not deploying. To delete this one. And remove that. Yeah, remove that. So let's see. Okay. Yeah, just a second. No, I need to do on this one. So I think I just need to just delete. Okay, interesting. Okay. Yeah, sorry about that. Let me just try to remove. Yeah, this is it. Let's try to CTL. Interesting. Okay. Just a second. Okay. Yeah. So let's go back to this. I think this one think they're all up apart from this product page. But we can just go on with this. So as I was saying, as you can see, we have like these two, we have like a number of containers that are being deployed. So this is going to just inject Istio container and do some configuration on it. So that will enable us, the Istio proxy, to be able to take the traffic that is coming in and those instructions and send them to the control plane. So since that is already deployed and we've already like deployed most of this workload, let's go ahead and deploy the now this service, the booking for service here. This gateway and the virtual service, this is what we need to deploy next. So to do that, we just need to apply the same command here. That is booking for gateway channel, and we're going to apply it in the demo namespace, right? So this is going to create like the gateway, and as you can see, this has been created. And if we go to here, I will come to this lens where we can simply see those resources. For instance, if we check here, we can see we have this extension like Istio. So these are a couple of operators that have been deployed, and we can come here and see whether our destination rule have been applied. Right now, we don't have like any destination rule, but if we check, we can see we have like a gateway that has been deployed, right? So this is a gateway. This will enable us to be able to connect with our cluster to be accessible, our service, or any service within our mesh to be accessible outside the cluster. And we can see we have also like a virtual service that has been deployed. And yeah, so for now we haven't like deployed like any destination rule, but we're going to do that shortly and see how that works. But to make sure this one is working, let's do some testing and see whether we can be able to access what we deployed on a browser. So going, if we come to a terminal here, and let's say, for instance, try to let's say kubectl and get just the gateway resource. And this is demo. This is the right command. Can try to get this. This. Yeah, so you can see this destination rule is it's waiting on port 80. So what we need to find is whether we have what we call it. We just need to find the port that we need to access it through. So in our case, let's go to a browser, and before we can go to a browser, let's describe. Let's do kubectl get all certificate inside the Istio system, and this is the egress. You can see the load balancer. It's yeah. So we're going to be using this and this port here to access the cluster. Yeah, so let's find a browser. We can just use this and let's try to do HTTP 37, and I think the port was let's use this port to see Will I be able to hit the sub? Okay. So for that to work, I think we need to give it a path. And in our case, this is in this product page. Let's try to hit this and see that it's going to work. So here. Just a minute. Let's see. Let's try this one. What am I missing? Pot. Just missing the pot. Mic check. Can you still hear me?
Check.
Someone?
I can hear you.
Okay. I think we forgot about see. Feedback. Why isn't this working? Okay. Man. Just give me a second as I try to troubleshoot this, see where I went wrong. Something went wrong. Okay. Okay, just a minute. Just this one and okay. Okay. Yes. Just give me a second. See where I got. Yeah. I think there's something I got wrong. Just make sure that this is running. Okay. Let's try to do it again. Found. Okay. So, okay. This is interesting. Just a second. Let's try to debug this. I really hate this when this happens when you're in a demo and don't. See, this is gonna take. Okay, it's even running. Okay. Okay. This one. This is not down. What's this one? Is that details? This one. Down. Loading. Load. Let's have this one. And let's just make sure that this port is still up. This is up. Yeah, so is that see, this is supposed to be working. Yeah, there you go. Yeah. Can you guys still hear me? Sorry. Mic check.
Check.
All right. Yeah, so this is now deployed, and this is the product page. And for instance, if we keep on, I don't know whether you guys can notice this here. There's something that is happening while we keep reloading this one here. Yeah, so this is a simple like application that usually is used to demonstrate the capabilities of Istio in regards to how you can do traffic management, and also you can also be able to deploy the various components of the traffic management API resources. And as we just saw when we did deployment, we deployed a couple of things here, and we deployed basically a gateway service, and that is what has enabled us to it just give us like a temporary load balancer to be able to view this on local host. So that's where you can be able to see this page. That will basically connect from allow us to connect from the client, which is the browser. The traffic goes through the gateway up to the virtual service, and then since you see here, we're saying that even if we were to change this, for instance, we were to change this and say we're just going to close. Then we see that we're getting an error here, because the rules that are applying here and not giving any exception for that. So that's what this rules are being applied. I can alternatively come here and play around with this and apply different rules, but in our case, it's just going to just stick to this. And since that's also kind of demonstrate how we can deploy this. Yeah. So to further explain what is really happening here, despite deploying that we just deployed the services, the virtual service and the gateway. We also have other resources. If we come back here, you can see we have different versions. So as you can see, we have version 1 on the view service, right? This version 1, and we also have another version. We have also review this the second version of review. We have review version 1 deployment and review version 2. So what is happening here is something simple, not as simple, but what you're seeing here, you're seeing when you try to reload this page a couple of times, you'll notice that these stars are changing colors, right? And from black to red, product to it, and then from this and then back to the one where you have like no stars at all. So on this product page, what is happening? Since this product page has a dependency on the review, if you notice when we deployed this, there were a couple of services that are deployed: the details, the products, the ratings, and the reviews. So what we are seeing here, we have like 3 reviews. We have reviews version 1, version 2, and version 3, which is defined on this page here. So just here. So I'm here. It's here. Like book info get to this service. So this service is applying all the traffic that comes to the gateway. We're going to apply all these rules. So that goes to this is a destination. This is where the destination, in our case, this is the page you're seeing here now. So we want every traffic that is coming to this page to go through the gateway. So from the gateway, we're going to apply the rules. So those rules are what are helping us to be able to view like the different versions of the review service. On this side is the book review sides, and this is the book detail side. So you can see this doesn't, the book detail side doesn't change, but on this other side we have this keep changing to review, because we have different versions, or we have different version of the same service running multiple times. So this is like a good example where you can have like well, this one of the advantages that come with Istio. You can be able to like be able to play around with traffic and rules to be able to according to your need. For in this case, we are saying that okay, we need to do it randomly with as in a round robin format. That's how we want to do to load balance across those 3 versions of our product page of our review service. So if we come here. Let's look at this one here. So if you look at this, this is the destination rule that we are applying for this one. So we have defined a couple of destination rules for the product version. So we only have like one version of the product page, but for the review, we have like a couple of subsets here. So we have version 1, version 2, version 3. The same thing for the ratings. For the details, we have different destination rules here that are being applied, right? And we can go ahead and try applying this, but I'm guessing this is already applied. No, not really. So we can do kubectl and demo. Let's apply these changes and info destination rules, and let's just pray something doesn't go wrong while we're deploying this. Yeah, so we've deployed the other destination rules resource, and if you come to this point viewer, you can see now at least you have destination rule defined for this, and as you can see the edge, this is what we just deployed right now. So these destination rules are going just to define like is basically defining which host, which version of host are we going to apply the rules to. So in our case with the reviews, we have like the version subset of the review service. So using this to apply the same rules, right? Just define what's going to happen when traffic reaches this host, right? So we want to have like this version, our traffic being routed to this version, but in a round robin manner, right? So that's it with the destination role. You've already like defined, and let's see whether these are ready, and still whether we can still access our service here. Yeah, so not much that it has changed because this one is still working the same. But I think you can always play around with this to see how you can work, or you can just get creative with these rules and customize them according to how you need. And basically that's it for the presentation, because I think we've looked at the gateway, the virtual service, and how you can apply. But let's just like go back to slides. And can you guys see my slide on screen here? Mic check.
Yes, we can.
Yeah. Yeah. So what we've just seen is we've deployed. We had a cluster. We set up a cluster. We deployed Istio. We were able to see how Istio also like kind of inject the sidecars. And from the diagram here, what we saw is after we installed, we enabled Istio service mesh within our cluster. We were able to deploy process as we usually do in Kubernetes using like YAMLs. And we just saw we could we defined like a couple of services, that is the detail, the review, the product page service, which is how we can deploy those. And we also saw how we can also we can control traffic that comes into a cluster and using virtual services, and how we can define routing rules. And also like got to look at this is what we just basically looked at, which is the gateway virtual service and destination rule. And this is basically how this would look like, maybe in a diagram. So we have a service running, and then after injecting, then we have like the sidecar that is injecting and is running alongside your containers. Yeah, so that's basically how Istio works. And this was just like a high-level presentation overview of how this you could implement Istio. So just an introduction. And in future, probably we're going to organize another talk where we go into details and look into things such as security and how we can do things such as observability. But maybe before we can close, let's first of all look at what we went through. We defined what service mesh is. We also like looked at Istio, what Istio is, and we said Istio is an open source platform, service mesh platform that allows you to be able to deploy a layer of network which can enable of an infrastructure layer that you can deploy within your cluster to enable communication among your services or components if you're using a distributed architecture. We saw like the virtual service, what a virtual service does. Basically, it defines the routing rules. We saw the gateway, which allows the traffic in and out of service mesh. Also, like give us like the load balancing capability. We saw the destination rule. So the destination rules, we also how we can define what happens to the traffic when it gets to the destination, that is the service. We also got to learn about the sidecars, which are like proxies that are deployed alongside your workload containers to enable you to which allows you to be able to the service mesh or Istio to be able to intercept traffic being sent in and out outside your traffic inside your service. So we saw this, and I think that's it for the summary. And I think if you do have a question, before maybe we can close things up, I think I would like to give you an opportunity to ask a question. If you feel like there's a suggestion you need to make, just feel free. This is the right time for you.
Yes, Tony.
Yeah. So first of all, thank you for all this introduction to the service mesh, guess, and I'm still trying to understand it. So give it an example of you're trying to deploy a microservice and microservice application, and let's say that your backend has two different microservices. So in order to implement it using the service mesh, would I need all those three components that you talked about? The gateway, the virtual service, and I forgot the other one. So would you need to define all those for a particular microservice, or you can use one for one specific scenario?
I think there are those that are kind of applies. For instance, let me just show you something quick. Very quickly. Just let me know when you can see my screen here. Mic check, can you see my screen?
Yes, I can.
Yeah, just let me, I hope this answers the question. So from example that we just did, we can see we deployed like a gateway, this booking for gateway, and the virtual service for this booking for services, right? But on the other side, we have like we have this, wait, just let me just get double to. We have this destination, we have this other service, which is HTTPK gateway, yeah, this file. And this also defines the, what do you call it? It defines different destination rules. But this specific to one like host or one service only, which is the HTTP KG service. So in our example here, we have simple, these are just deployment, but these are specific to this one microservices, which I'm calling HTTP package. So if I'm to deploy this, if you notice here, like, okay, these are just the same Kubernetes. These are just Kubernetes. These are separate resources that I'm defining for the service. And I have like different definitions for, I have different files for that as well. So if I was to deploy this, it's the best practice is to like define the gateway once, right? Because this will remain the same throughout. And you can reuse this across like different with different virtual services, because when you deploy a gateway, you have to select define like a virtual service that will apply the routes the way you like define the routes for your traffic. You know? So here we can still like reuse the gateway that we deployed first for book info. We can simply like just maybe try to comment this out here. Just to try to comment this out and see what would happen if I was to, for instance, just, let me just get, where is it? Let me just get this closer to the other tab so we can copy things around. So we have this book info gateway. And this is what, since we already deployed this book info gateway, we're going to reuse that. And in this case, we are going to, now, since we are going to define a new virtual service, but we're going to reuse the same gateway here. So we are referencing that from what we did before. And if we were to apply these changes now, for instance, let's come here and try to say this file is deployment. So first of all, let's deploy this, the service itself. Say, I'm going to apply the same on, say, apply this deployment to -n, the demo, right? It's the namespace. So this is going just to deploy. We check the pods. We can see there's an extra like 2 services that have been added here, which is the HTTP package, and it is a simple service that print like different colors and stuff. But that's deployed. Now let's come to now and try to also deploy this other resources, traffic management resources. So we can do HTTP, and so this is going to create like the gateway service, the virtual service, the destination rule. So those have been created, and you can see here we didn't create like any gateway on our side. We only create the virtual service and reference the one we created earlier on. Yeah. So if we check, we come down here and check, for instance, see, we only have one gateway, but for virtual services we have like 2. No, one for booking for, but the name is different. Okay, I think I forgot to like change the name. I think the description. Oh, but you can see here, okay, we have like the same virtual services. The virtual services, we have 2 different virtual services, but they're referencing to the same gateways. See, you're referencing the same load balancer, so you can still like reuse these 2 these components. So the only thing you need to define differently for your services or for your hosts is the virtual service, because you want to apply different rules to different services. But if there are those services that you want to apply like the same routing rules to, you can replically use the same virtual service, and you could actually add multiple destinations. Like in our case here, we have this virtual service. So in our case, you can see we have like two destination, but which is like the same. It's just the same version, but 2 different versions of it's the same application, but 2 different versions. So if you were to check this one out, the prefix is this one. So if you were to see whether, let's just see whether this one is working out or it's just there. We can get this to work, and let's try to use Postman for this. And this is localhost. Yeah, so this is let's try to reach this. This seems unavailable. Can try this one. Somehow this one doesn't work. Just a minute. It comes here. This won't work. Yeah. So that won't work right now. I don't know why. But let's try to debug it a bit. Let's see. Just a next kitchen. Page. Okay. Interesting. But I don't know if I answered your question, because I think it was already like past time. So I think this is going to take some time to like debug what's happening. But I think it's just some configuration I got wrong. I think I can just look at that later on.
Okay.
But maybe let me just try to just a minute. Let's try to remove what we just did here. Say delete this, and let's just do here. Yes. So then let's apply this again. So this actually deploys another gateway, and if we can check this, whether you have a gateway, you can see at least now you have 2 gateway running. There's a newest one here, like just loading right now. And Yes, so see, let's give it some time, see whether it should come up. Basically, there's something I'm doing wrong. I think we can always solve this some other time. But I think for the demo, so what I was just trying to demo is how you could use, like, for instance, we just use like two microservices we applied the same, we used like different microservices, but we kind of used is that the example? Yeah, so in our case here, like you can see, as we only like define like this only once, and for instance, we also, for the destination rules, we also like define them like once in one page for all the for all the services that we need. So I don't think like it's a big deal in terms of how many files you need to like create for you to be able to like deploy these components. But I think if you have many microservices, there's a way you could basically manage the virtual services. The virtual services way better, depending on what kind of traffic you need to apply to like a certain subset of like your services. So yeah, but I think with these simple with these few components that we went through, which is the destination rule, gateway, and virtual service, I think this would be like enough to like get you started into Istio. As you saw there, we were able to apply like rules. So for instance, we went through the URL, we wanted to like exact this to exactly uh, take the traffic that exactly like if we hit this URL, then it has to match this exact path for us to be able to reach that. And this we do like route-based routing, path-based routing. We're using like route path-based routing to like match as our rules to like match a path to a specific service. So I don't know if that makes sense, but yeah, basically this is what you need. Just define the rules that you want to apply to your traffic that comes that is going to your destination here, and just deploy a gateway to allow traffic in and out of your service mesh. And to fine grain what you really need to happen to that particular destination and that traffic to get to that particular destination, you can define destination rule to have like granularity. And you can also like use this destination rule to have like different version of your application, and you can play around with routing, see how whether you can use like different types of load balancing based on there are a couple of ones supported. There's this request, there's round robin, there's also like weighted load balancing type. So you can just play around with this and see what works best for you. And just to close up some other maybe some bonus, maybe for bonus. There are many things you can do in Istio apart from what I just mentioned here. And I think it would be like good if you went ahead and maybe try to do it yourself and see how maybe you can just play around with Minitube and it and see how that goes. And I think I'm going to end my presentation there for today. And I think I'm hoping maybe to do another one on Istio where we can go deeply into how we could do like include security, such things such mutual TLS between communication between services, and yeah, how we could also like do things such as retries, such as retries, timeouts. How we could also like make sure that our microservice architecture is fault tolerant. Istio also enables you to like be able to like inject, which is kind of like try to inject faults into your errors into your infrastructure layer or network layer to see how your applications behave in case maybe that happened in a production environment. So those are just good things that you can do with Istio. This is just like a beginner on how you can use the production, and I think I've come to an end I hope you guys learned a lot from it. If you do have any questions, suggestions, feel free to drop them on the channel or just ask. Yeah, that's it.
Okay, thank you so much, Gidraff, and for everyone for joining the meeting. And I think I also don't have anything else. So I think we can end our session there. Is there anyone who who is not in our community and would like to join our community? Anyone who is currently not in our community? Okay, so I think everyone is in the community, so we can end our session there.
Awesome. See you guys. Have a great evening.
You too.